Welcome to video 15 for Chapter 6 Bone in Anatomy and Physiology. We're going to look in this video at how bone repairs itself after a fracture occurs. So you've gone to the doctor, they might have had to reset your bone, they put it in a cast. So we're looking at 4 diagrams here. We're not really going to label these diagrams all that much other than to say that this refers to 1, 2, 3, and 4. And we're going to list what is occurring in each one of these diagrams and refer up here. So the first thing that happens, the bone breaks. If the bone is not lined up properly, a doctor can go in and either manipulate the bone while you're under anesthesia, or they can operate. They might have to put screws or plates in to align the bone. But you can see that the gap fills in, and this is actually called a hematoma. And basically, that is just a blood, it literally means blood tumor, but it is just a mass of blood. So this is a localized mass of blood because remember, through those Haversian and Volkmann's canals, we have all these blood vessels. We have blood vessels in the periosteum that travel the nutrient arteries that feed the bone tissue. So the bone does bleed, and we end up with a clot forming. So the hematoma forms, clot forms due to fibrous proteins in the blood. So the blood platelets go through a series of reactions and a clot eventually forms surrounding the bone. So it does cause a little bit of swelling. Inflammatory process is occurring, so the area swells. There's a lot of pain. And what happens is the breaking of blood vessels at fracture site decreases the blood supply to the bone. Some of the bone tissue dies, which increases inflammation and edema. So if you remember, edema is swelling. So there is going to be a little bit of death of the bone tissue. And that leads us to part 2 here. So you can see that looks a little bit different. So with part 2, this is the formation of something called the callus. And the callus is a mass of tissue that connects the ends of the broken bone. And this mass of tissue is triggered when macrophages eat the clot. So the macrophages come in, those are part of the inflammatory process. They come in and they start breaking down this clot. So they basically eat it because remember, macrophages are big eaters. And then that is going to trigger a series of reactions that results in a formation of tissue. And we end up actually with 2 calluses forming. We have an internal and an external. The internal callus is between the bone ends. So in a diagram up here, that's going to be in this area here. So if we just extend the line down, that would be inside these 2 ends of the bone between there. This usually is going to be fibrocartilage that forms. So if you remember, it's a denser type of cartilage that forms in between there, and it's going to be a lot stronger. So it's like dense connective tissue that forms. The external callus is around the internal callus, and periosteum. So this actually forms a barrier around this and kind of seals it all in. And this is for protection and stability. Now, if you do not get medical treatment for a broken bone, this is going to occur. And sometimes if you don't know that you broke a bone and this starts forming, they will have to go in and either surgically break the bone again, and then this starts all over again. So here you can see that we have this external callus right here forming with the internal callus inside. Our third one, you can see that this is starting to reduce a little bit, and then this is starting to turn into bone. So our third step here is callus ossification. So we form spongy bone. And this takes about 3 to 4 weeks or so to start ossifying. And then that's why we have to wear a cast for upwards of 6 to 8 weeks, because this spongy bone starts forming about week 3, 4, but it's still not fully formed. And it's going to be weaker because remember, spongy bone has a lot of spaces and we need that layer of compact bone to form. So during this period, it is important to mobilize the joints above and below the break. So with that, if you were to break your ulna or radius, the bones of the forearm, they're going to immobilize your wrist and possibly your elbow. Depending if you break your wrist, they're going to mobilize your hand bones and your thumb and your ulna and radius. So it'll be on your forearm upwards to your hand. So they try to limit that motion. So a lot of times if you break your tibia, which is your lower leg bone, your ankle and your knee are going to be immobilized. But it also depends on where the break is. So some bones, they might not be able to immobilize fully. If you break your pelvis, you can get a body cast, but a lot of times you'll be bedridden for a while. There are other bones, your humerus. That is usually one that you might see depending on where the break is. Somebody has partly like from on the side of your arm, and you have like a metal support that goes down to your body to mobilize your shoulder. So if you have a cast, this is why, because you need that bony, spongy bone to form to help solidify the break. And then our fourth diagram is bone remodeling. So we've covered this bone remodeling, but we have compact bone replacing some of the spongy bone, especially on the outside. So if it is a long bone, we'll end up with the marrow cavity again, and we'll have a little bit of spongy bone, but compact bone will replace it. The external callus is reduced by osteoclasts, so there'll no longer be a large bump, so they'll go in and remodel that. So that's once the bone is healed. But there will be a very faint scar, so a bone scar remains. So it actually ends up being a little tiny wee of a bump, and that tissue is just a little bit different. And you can see that a little bit in a diagram that they show this here. So that's kind of like a bone scar. So you can actually see by looking at an x-ray if somebody has broken bones before. And this is one way that they can identify bodies sometimes, is based on what bones were broken and where, because they can look back in the medical records.